say we have this thing here. I'm just taking a question from the list, and I have to verify whether it says we have to check whether it's absolutely convergent or conditionally convergent, or right. So see, this grows in the powers of n, right? This keeps growing by factors, right? So ratio test is very appropriate for this to use. All right. So for ratio test, what we do, we just take the n plus 1th term. You're familiar with that, right? Okay. Over n. Beautiful. All right. So then we got this. So what we have is that you got 10 to the n. I'm going to ignore the negative sign because we have absolute values here, right? 10 to the n plus 1 over n, oops, n plus 1 factorial, right? That good? Now, since I'm dividing by an, and so I'll have a fraction divided by another fraction, so the bottom one can be flipped, right? So instead of writing all those details, I'm writing it like this. That's right. Makes sense? Then you have 10 to the n plus 1 when cancelled by 10, it will reduce to what? Just 10. Very nice. Now, this thing, factorial n plus 1 is here and factorial n is there, right? So what happens then if I start breaking factorial of n plus 1 down? I will have n plus 1 times n minus 1, etc., etc. So the next factor is the factorial n itself, right? Okay. And then I still have this coming in from the top. And what these two will do to each other, they will cancel, right? So we have say that again. Okay, I'll explain. So let's quickly review factorials. So like say I have 7 factorial. So 7 factorial is what? 7 times, oops, sorry. 6, I do that, 6 times, 5 times, 4 times, 3 times, 2 times 1, right? Now, if you look at this whole thing here, what is that? That's 6 factorial. So I can write this as 7 times how much? 6 factorial, right? So just the same way, I'm expanding this, right? So I went n plus 1, and again the rest of the expansion will be like this, right? Okay, so that just became factorial n. Is that sounding better? So they cancel, right? Now what do? We take the limit. And limit is what? That's 0, and that's less than 1, right? So this series converges absolutely, doesn't it, right? Now, if a series converges absolutely, it converges like even if we throw in negative signs at as many terms as we want, it's still the series will be converged. So we were able to determine it, right? Yeah, right. So let's see if it goes to a point or not, right? Okay. It converges absolutely, right? So we will see. Let's see if it goes to a point. So what are we doing here? And you are used to doing this by using sum sequence, right? So I'm just doing the sum sequence kind of thing here. So say if I added the first 100 terms, it became this dented, right? Now we're testing for convergence. You can just say I went 1,000 terms, all right? Is it changing to actually now it has stabilized, like even up to 100 terms it just became almost negative 0.999, etc., etc., right? Now even for absolute convergence. So right here for absolute, and I'll email you a transcript, so you don't have to worry about writing anything down. Okay. So see this here. We are checking for absolute convergence now, right? Okay, because we saw it's absolutely convergent, and absolute convergence will be this. Okay. It's gigantic, but it still is just it stays there, right? Doesn't it? Right? See this here. Okay. While if it was not convergent, okay. So let's take example of a series that is not convergent. Okay. Oh, all right. Say for instance, yeah, give me example of a series that's not convergent, right? So you're going to give me example of a series that's not convergent, right? Okay, yeah, tell me. Okay. 5 times n you mean? Okay. All over 6 times n minus. Oh, okay. All right, I got it. Yeah, because otherwise it won't work. You say, right? And you got it very well. Very nice. Good. So that's what it is. First of all, tell me why is it not convergent? Why? Let's see. First of all, if you took the limit of the nth term, remember this? If the very first condition that any series has to satisfy in order to be convergent is that the limit of the nth term must be 0. All right? And in this case, you can see this, even if we dropped this, what the limit of this quantity is. So that means what? If I say brought even this sign in, it'll be oscillating between these two values, right? So does it get to 0? No. So convergence is ruled out right here, right? Okay, makes sense? Now, we want to see this non-convergence phenomenon. Okay, so let's look at that. So say, and so it should be oscillating, right? And since it's a capable packet, and you can see oscillation will be really interesting to see. This here goes this, and then let's put that. Well, let's just go 101, right? Okay. All right. So 200 is that, right? So of course, right? You can see it's much different. Let's go 1,000. It went close. See this here? Well, it will be, and let's go like 1,000, and I'm just randomly throwing big values, right? So see this here? Now, if I had done this, like say, and if you look at the positive portion only, right? So you will see that, so you got that, right? That you got when you got, say, 1,000, this is 8. See this here? So what's happening is, see, till 2,000 terms at 834 point, etc., etc., right? And 5/6 was the limit of that nth term. So just to notice it, it's got 5 over 6 times what? 1,000. So notice that, right? So anyway, so that was behavior of a divergent series. And if you look into the other, the other commentaries, there are many of these like this, right? Okay. So exactly, divergent is diverges. I mean, if something, right? Exactly. I mean, so and convergence converges to. point. That's what you've seen, right? Makes sense. So, and make sure you practice many like this with your sum sequence features. All right. The sequence converges to that. That's what it means is if I had, say if I was talking about this, this is simply sequence of numbers, right? Okay, makes sense. Okay. Okay. So it's just like this. Say for instance, if somebody is incurring a loss every hour, all right? So, and the loss is like decreasing and decreasing, and it may be converging to zero. It may be. But when you add all the losses up, all right, it still maybe become a gigantic quantity, right? So sequence is converging, right? They're saying, okay, we are tapering the losses down, right? Okay, but when we are adding them all up, right, it's still like not. So all it says is this converges, right? So we're just mixing things up a little conceptually. So hopefully we'll be good. Okay, converges to this, and you just saw an example right here. But if we just add these guys up, one adding it up, right? What will happen eventually in here? Say all the terms are say positive. We just keep on adding this to itself. So that's why even if it converges to zero, it's still the convergence of series is not guaranteed. I gave you an analogy, right? Okay, makes sense. Like say this here, this. Uh, we have to remember things like this. Like this one, like such things now we have to keep in mind, just like red means a stop, right? Okay, so tell me whether this is convergent or divergent very quickly. Why convergent? Okay, this goes to 0, but still I'm saying it is not convergent, right? Yeah, that's what I was telling you about. That is even okay. So let's look at the phenomena first, okay, and then we will look at the what what happens is it's still say this here. This is 18, right? Okay, just goes up even though slowly, right? And I did what? Let's go to that, and I would see this. Just throw in a few more terms. Okay, this time on this here. Yeah, okay, makes sense. Okay, so one thing remember, see, this is like as I said, this is like you have to keep in mind the traffic signals. Okay, remember you use the integral test to determine this, okay? And watch the video that I have posted on that because we have, say if I have this series, it converges if and only if what p is uh, greater than, because see yeah, because see it's in the yeah, if and even if p equals 1 it diverges, remember that. Basically it is like n to the 1 half, right? Okay, okay, good, yeah. And what else is confusing?